Okay, this is the next lesson in Algebra 2. Again, we're still in Unit 5, Radical Functions. And this lesson is called Solving Radical Equations. Okay, so a radical equation is an equation that has a variable in a radicand or a variable with a fractional exponent. If the radical has an index of 2, then that's called a square root equation. That's just a specific kind, okay? We're focusing on all radical equations today. I think most of them probably will be square root equations, but we're doing radical equations in general, okay? So to solve a radical equation, you're going to isolate the radical on one side of the equation and then raise both sides of the equation to the same power, okay? So example 1. Solve 2 plus the square root of 3x minus 2 equals 6. So first what you have to do is you have to isolate the radical. You have to get the radical by itself. So I'm going to subtract 2 on each side of the equation, and that gives me 3x minus 2 equals 4. That should be a 2. Okay, because you subtract 2 on each side of the equation, and you get the square root of 3x minus 2 equals 4. Now what I'm going to do, and I'll do this in the next step, just to show you. You can do this all in one step if you want. But what I'm going to do is I'm going to raise each side to the second power. Because what is the square root of 3x minus 2 squared? That means what is the square root of 3x minus 2 times the square root of 3x minus 2? And that equals 3x minus 2. Because square rooting and squaring are inverses. It's basically like if I were to say, what's x plus 10 minus 10? It's just x. Okay, so 3x minus 2 equals 16. Okay, solve that for x, so add 2 to each side. 3x equals 18. Divide by 3, you get x equals 6. Now, that's great, but you have to check over all of your answers for these problems because sometimes you may run into an answer that doesn't actually work. So I'm going to check my answer on the side. I'm going to do 2 plus the square root of 3 times x, which is 3 times 6, minus 2. So I'm checking my answer to see if it actually works. So 2 plus square root of 3 times 6 is 18 minus 2. So 2 plus the square root of 16. 2 plus 4 is 6. So my answer does work, okay, because I did get 6. It's supposed to equal 6, remember? This 6 should be the same as that number. It's just a coincidence that it's also the same number as that. I was checking to see if it equaled 6, and it does. So x equals 6 is my answer. Example 2. Again, isolate the square root. Isolate the radical. So add 6 to each side. It gives you the square root of 5x plus 1 equals 6. Add 6 to each side. Now, you might be able to skip some steps. I'm not going to skip any steps. I'm just going to show you everything out. But what I'm going to do is I'm going to square each side. I'm just doing that in the next step so you see it better. So the square root of 5x plus 1 squared equals 5x plus 1. 6 squared equals 36. Solve it for x, so subtract 1. 5x equals 35, and x equals 7. Now we have to check our answer to see if that actually works. So let's check our answer. We have the square root of 5 times x, which is 5 times x, 5 times 7, plus 1. And that's all going to be minus 6. Under the radical, we have 35 plus 1 minus 6. So that means we have the square root of 36 minus 6. The square root of 36 is 6. 6 minus 6 equals 0. That works. It was supposed to equal 0. Okay, it was supposed to equal 0, 0, 0. Same thing with number 1. This 6 was supposed to equal that 6. It's just a coincidence it was the same as that 6. Okay, but back to number 2. That 0 works because it was supposed to equal 0. So it means x equals 7 is an answer. Moving on to page 2. I think page 2 is the most difficult page. We have 3 pages, we have 6 examples, and I think examples 3 and 4, these are the hardest ones. Okay. You can solve equations of the form x to the m over n power equals k by raising each side of the equation to the power of n over m. So the reciprocal of this. If the nth root of x is the real number, then x to the m over n raised to the n over m equals the absolute value of x. What does that even mean? All right, let's do some examples to see what that actually means. Okay, because that was pretty wordy up there. Okay, example 3. Let's solve this equation. What I'm going to do first is I'm going to divide each side by 2. When I do that, I get x minus 2 to the 2/3 power equals 25. So now what I'm going to do, I'm going to do this in the next step because I don't want to combine any steps. I'm going to take each side of the equation. Actually, you know what? Let me just do one thing first. I want to give myself more room. Okay, here we go. I just want to give myself more room. Okay. So again, all I did so far was I divided each side by 2. Now what I'm going to do is the following. I am going to raise each side to the reciprocal of this. This is 2/3. Okay. This is 2/3. So the reciprocal of 2/3 is 3/2. So I raise each side of the equation to the 3/2 power. And again, I'm doing 3/2 because that's the reciprocal of 2/3. Okay. So what that gives me is on the left, 2/3 times 3/2 is 1. So there's no more exponent. But if you read above, what we have to do is we're left with x minus 2, and we have to put that in absolute values. Absolute value of that. Okay. On the right, what I'm going to do is I'm going to rewrite 25 as 5 squared. Okay. Because if I do that, 5 squared to the 3/2 power equals 5 to the 3rd power. And what is 5 to the 3rd power? 5 times 5 times 5 is 125. Okay. Now, absolute value is a topic you learned in Algebra 1. For example, the absolute value of 7. If I say what is the absolute value of 7, that equals 7. It's how far away it is from 0. If I say what is the absolute value of -7, that also equals 7. Okay? So what you do for these problems, whenever you have an absolute value problem, you're going to write 2 equations. One equation is going to be x minus 2 equals positive 125. And the other equation is going to be x minus 2 equals negative 125. And you solve each one. X equals 127. X equals negative 123. So now what we have to do is we have to check each of those answers to see if they actually work. Let's start with x equals 127. In my original equation, 2 times x minus 2, 127 minus 2, raised to the 2/3 power. 127 minus 2 is 125. 125 can be thought of as 5 to the 3rd power. 5 to the third times the 2/3, multiply the exponents, and you get 2 times 5 squared, which is 2 times 25, which equals 50. So it did work. That means x equals 127 is a solution. Now let's check the other answer. Let's check x equals negative 123 and see if that works also. Okay, so that means I have 2 times x minus 2 from the original problem, negative 123 minus 2. It gives you negative 125 in parentheses. Think about it like this. Negative 125 is negative 5 to the third power. So if I have negative 5 to the third power to the 2/3 power and you multiply the exponents, that gives you negative 5 squared. Negative 5 squared is 25. 2 times 25 is 50. So that answer also works because it's supposed to equal 50. So both of these are answers to that problem. Again, I think this is the hardest page in this lesson. Okay, examples 3 and 4 are the hardest examples. Let's do the same thing for example 4. First, I'm going to divide each side by 2. So I get x plus 3 to the 3/2 power equals 27. Then what I'm going to do in the next step, I'm going to raise each side of the equation to the reciprocal of 3 over 2. It should be the 2 over 3rd power. So on the left side of the equation, that gives me x plus 3, but I have to put that in absolute value symbols. Equals 27. Think about 27 as 3 to the 3rd power. Multiply the exponents. That gives me 3 squared on the right, which is 9. It's an absolute value equation. You're going to write 2 equations. One will be x plus 3 equals 9. The other will be x plus 3 equals negative 9. So one answer I get is x equals 6. The other answer I get is x equals negative 12. But you must check over each answer because sometimes the answers will not work. We haven't had any that did not work yet, but maybe this one won't work. Let's start by checking the first answer. Let's check x equals 6. That was one of our 2 answers. Let's check that one first. Okay, back to my original equation. 2 times x plus 3, so 6 plus 3, to the 3/2 power. That's 2 times 9. Let me rewrite 9 as 3 squared. By doing that, when I multiply the powers, I get 3 to the 3rd power. 2 times 3 to the 3rd power. 3 to the 3rd power, 3 times 3 times 3 is 2 times 27, which equals 54, which it was supposed to equal. So that means that answer, x equals 6, works. Let me circle that. That answer works. Well, let me box that in. Now let's check x equals negative 12. Let's see if that one works. Check x equals negative 12. 2 times negative 12 plus 3 to the 3/2 power. That means you have negative 9 in parentheses. All right, so I'm going to do something a little weird now. I'm going to take out the negative 1. I'm going to rewrite it like this. By taking out the negative 1, because multiplication, it doesn't matter which way you multiply. 5 times 8 equals 8 times 5, for example. 2 times negative 1 is negative 2. Let me rewrite 9 as 3 squared. Let me do it a little neater. I did it a little messy. Hold on one second. Okay. Let me rewrite 9 as 3 squared. I could not do that with the negative 9 above. Okay. But by doing that, if I do power to a power and multiply, it gives me negative 2 times 3 to the third power, which is negative 2 times 27, which is negative 54, which does not match what it was supposed to match. So it means this is not an answer, okay? Does not match. It means negative 12 is not an answer. It's called an extraneous solution. So don't circle that and say that's a solution. It's not. It's called an extraneous solution. So it's not really a solution. Okay? By doing this, like something weird happened, something funky happened. So you ended up solving that, getting x equals negative 12, but it doesn't actually work. It's not an answer. So don't circle negative 12. Okay, on to the last page. Solve these 2 more equations to solve. Again, you have to isolate the radical, get the radical by itself. So for this problem, I am going to subtract 5 on each side to get the following. Now I'm going to square each side of the equation, like so. On the left, I get x minus 3. On the right, hopefully you remember this, the shortcut. X minus 5 squared means x minus 5 times x minus 5. So if you don't know the shortcut, or if you don't remember the shortcut, what you have to do off to the side is you would have to actually do x minus 5 times x minus 5, and you would have to distribute. Okay? But that takes a while. I don't like to do that. I'm going to use the shortcut, which we talked about earlier this year. X minus 5 squared. Square the first term. Multiply the 2 terms together and double it, so a negative 10x. And square the last term. Now what I'm going to do is I'm going to get this equal to 0 to solve. So I'm going to subtract x on each side of the equation. So I get x squared minus 11x. I'm going to add 3, so it equals 0, so plus 28. And now I'm going to solve this quadratic equation, which goes back to unit 3. And I'm going to do that by factoring. What 2 numbers multiply to 28 and add to negative 11? Think about that. Multiply to 28 and add to negative 11. It'll be negative 7 and negative 4, okay? Because negative 7 times negative 4 is positive 28. Negative 7 plus negative 4 is negative 11. Solve each. X minus 7 equals 0, and x minus 4 equals 0. X equals 7, x equals 4. But let's check each answer and see if they work. I'll start with x equals 7. So we have the square root of x minus 3. So 7 minus 3 plus 5. The square root of 7 minus 3 is the square root of 4 plus 5. So 2 plus 5 equals 7. It was supposed to equal x, and in this case, x is 7, so this one does work. So let me box that answer in, because x equals 7 is a solution. And I checked it, and it works. Let's check our other solution, x equals 4. So we have the square root of 4 minus 3 and plus 5. So the square root of 1 plus 5. The square root of 1 is 1. 1 plus 5 is 6. So that one does not work. Okay. X equals 6 is not a solution. So I did in the last one, I'll just put an X there. Why not? It was supposed to equal X, and X is 4. Supposed to equal X, X is 4. We got 6. It's not an answer. So it's called an extraneous solution. I'm just going to label that. So don't circle X equals 4. Not a solution. One more. Subtract 3 on each side so you get the square root by itself. Then we're going to square each side of the equation. Like so. Squared. Squared. Okay, so what do I get left over on the left? 5x minus 1. On the right, x minus 3 squared. If you can't do the shortcut, okay, again, if you cannot do the shortcut, what you have to do off to the side is you have to do x minus 3 times x minus 3, and you have to distribute. If you don't know the shortcut that we did earlier this year, you're going to have to do this out to the side. Square the first term, x squared. Multiply the two terms together and then double it to get negative 6x. And then square the last term to get plus 9. Solve this equation. I want to get it equal to 0. I'm going to subtract 5x on each side to get x squared minus 11x. I'm going to add 1 to each side to get plus 10. Factor. What two numbers multiply to 10 and add to negative 11? Think about that. Multiply to 10 and add to negative 11 will be x minus 10 times x minus 1. Solve each of these. X minus 10 equals 0, and that yields x equals 10. X minus 1 equals 0, and that yields x equals 1. Now let's test each solution. Let's start with x equals 10, and let's see if it actually works. In my original equation, 5 times x, so 5 times 10, minus 1, and then it's all going to be plus 3. So it'll give me under the square root 50 minus 1, and then plus 3. So square root of 49 plus 3. 7 plus 3, which is 10. So that one does work. Because it's supposed to equal x, and x was 10. So this one works. Let me circle that. I'll box that in. Okay, and let's check our other solution. Our other solution for this problem, we got x equals 1, so let's check that. Square root of 5 times x, so 5 times 1 minus 1 plus 3. Square root of 5 minus 1 plus 3. Square root of 4 plus 3. So 2 plus 3 is 5. It's supposed to equal x, and x was 1, so this one does not work. So don't circle that answer. If you want to label it as an extraneous solution, that's what it's called. Just make sure you don't circle x equals 1. And that is the end of that lesson. That lesson was called Solving Radical Equations.